So yeah, hello everyone. I hope I'm audible and visible. Can anyone confirm it? Okay, let's wait for 5 more minutes so that anyone want to join this session, they can join. Okay, so now let's start the session. A very good evening and warm welcome to all of you. My name is Pooja Verma. I am the MRF Research Scholar from IIT Kharagpur. And this is a week 3 live interactive session of signal processing techniques and its applications, where we will solve the assignment questions and problems which is very similar to your assignment problem. And instructor for this course is Professor Shamal Das Mandal, Advanced Technology Development Center, IIT Kharagpur. I would like to suggest to you to keep one calculator with you so that we can solve the assignment problems it will be required during the solving the questions. And also you can use the chat box for answering the question and interacting. Okay. I hope I'm visible and audible. Can anyone confirm it? Okay, it's not audible. Okay, we'll try. Yeah, okay. So I hope all of you gone through the video lectures of this week. So here I am going to describe some basic or some theoretical points which is required during the solving the problems. Okay, so I will go through the first the basic theoretical points, then we will solve the assignment problem. Okay, so for this week, the topic name is Z transform. So first, what is a transform? Transform is a change of representation. Is called transform. And Z transform of a disk is represented for discrete time signals. It is defined as a power series. So of Z transform is defined by x of z of any signal x of n. It is represented as x of z is equal to n is equal to minus infinite to infinite x of n z to the power minus n, where z is a complex variable and it is represented by r e to the power j omega, where r is a magnitude and omega is a corresponding angle. Okay, so r is omega. And as you know that e to the power j omega is defined by cos omega plus r j sin omega, and r is a common factor, so r cos omega plus j r sin omega. And the z transform with a frequency domain representation of a time domain signal x of n. Okay, so since z transform is an infinite power series, it exists only uh, for those values of z for which series converges. The region of convergence of x of z is set of all values of z for which x of z attains a finite value. Okay, so the x of z is a z transform representation of signal x of n, and similarly x of n minus n naught represented by z to the power minus of n naught x of z. Okay, this is a plot of z to the power n, where this is a real axis and this one is the imaginary axis, and this circle represents the unit circle where r is equal to 1. This is the magnitude. Okay, so if poles are outside the circle, it is called it is the signal is represented by this is also called unstable system if poles are outside the unit circle. If poles are on the unit circle, then this is the oscillatory function like this. If poles are inside the unit circle, then this is a stable system that will converge at the end. Okay, so what are the some properties of ROC? Already this has been described in the video lecture, so I am here recapitulating these points so that we can use in the assignment questions. Okay, so normally ROC does not include any poles. And what are the some functions of finite duration signal? The causal signal ROC will be entire Z plane except Z is equal to 0. And for anti-causal signals, ROC will be the entire Z plane except Z is equal to infinite. And for two-sided signal, ROC will be entire Z plane except Z is equal to 0 and infinite. Okay. And for infinite duration signal, what will be the ROC? ROC will be the outside of the circle in the Z plane for infinite duration signal. And if signal is causal and right-sided signal, and if signal is left-sided signal and anti-causal, then ROC will be inside the circle in the Z plane. Okay. The two-sided signal ROC will be a ring in a Z plane. And for stability, ROC includes unit circle in a Z plane. Okay. So already this have been covered in the video lecture. I am just recapitulating here. Okay. So what are the Z transform of different signals? Here we will use these formulas and these Z transform during solving our assignment problems or questions. Okay. So the signal x of n, Z transform is represented by n is equal to 0 to infinite x of n z to the power minus n, and the Z transform of delta function is always 1. Okay. So I think you have gone through these questions, these formulas, or have you been solved? So just see here, we will use this while solving our problem. Okay. The next concept is initial value theorem and final value theorem. The most of the question based on these 2 points also. This will be helpful for you. So initial value theorem is represented by x of 0 uh, is equal to limit z tends to the infinite x of z. This is to find out using this formula. And the final value theorem is represented by x of infinite. You can say that where limit n is to infinite for x of n, and while it is represented in the z transformed z domain, so limit go on to the z to the 1, z to the power minus 1 x of z. Okay. And the next one is the inverse z transform. The procedure of transforming frequency domain to the time domain is called inverse z transform. The inverse z transform formula is given by x of n is equal to 1 upon 2 pi j integral of contour function x of z z to the power n minus 1 dz. And what are the different methods which we are find out the inverse z transform? First one is direct evaluation of the equation based on a contour integral, that is a Cauchy integral, and next one is a power series expansion or expansion by long division, and last one is a partial fraction expansion. We will see in the upcoming problem these methods. Okay. So now these are assignment 3 problems. Okay. So first question is the Z transform of a given signal x of n is equal to 2 del n plus 2 plus del n plus 1 plus 3 del of n plus 3 del n minus 1 minus del n minus of 2 is what is the correct option for this question? So first you wanna try, or I should solve the question directly. This one is a very basic question. So I hope all of you gone through the lecture. Okay, first I will try to solve this part, and after that we will directly put the values of this. So how you will represent the 2 del n plus 2 in the z domain. Okay. So this one is first I am considering only this part. So this one is will be our x of n. So x of z, what will be the x of z for this? Formula is n is equal to minus infinite to infinite x of n z to the power minus of n. Okay, so x of n here up 2, n is equal to minus infinite, so infinite 2 del n plus 2 z to the power minus n. So this is the delta function. So at n is equal to minus 2 is the only unit, one pulse is there like this. The value of this function is 1. So 2 will be outside of this. So what will be the at n is equal to 2? The value of this function will be 1 only. So z to the power, what will be the value of n is equal to minus 2? So minus and minus will be plus. So what will be the value of 2? Z to the power 2. So for this is the value, and similarly we will take all these values of this. So what will be the Z transform of overall function? So Z transform of overall function is represented by 2z square, yeah, plus this is del n plus 1. So what will be the value? There is a no constant. So only z to the power 1, but it can be written as only z. And next one, 3 del of n. So 3 del of n, that means at n is equal to 0, the value will be 1. So only the constant 3, and plus this is at n is equal to 1, the value will be 1. So this will become z to the power minus 1 minus, there is a minus sign. So this is minus z to the power minus of 2. So what will be the correct answer for this? Just match this with the answer. The answer is C. C is the correct answer for this question. Okay. So are you guys are solving with me or just listening? Try to answer this question in the chat box. Okay. So the correct answer is option C. Okay. So the next question. So the next question, the ROC of the above signal, which is we have discussed in the first question. X of n is equal to 2 del n plus 2 plus del n plus 1 plus 3 del of n plus 3 del n minus 1 minus del n minus 2 is given by. So have you seen in the properties of the ROC? Here it is written as if finite duration signal have if a signal has a finite duration and causal, I mean finite duration, then the ROC will be entire Z plane except Z is equal to 0 and infinite. Okay, just I am showing you once. This is a two-sided signal ROC will be entire Z plane except Z is equal to 0 and infinite. So here our signal is two-sided. It represented it n equal to minus 2, minus 1, then del of at 0 and n is equal to 1 and 2. So our signal is two-sided. So ROC will be the entire Z plane except Z is equal to 0 and infinite. So the correct option of this question is option D. Okay. Okay, so the third question is the Z transform of the signal x of n is equal to 1 by 2 n plus 3 u of n plus 3 is, what will be the Z transform of this signal? Would you like to solve this? I hope all of you gone through this type of questions already during video lecture. Okay, so as you know that x of z represented as n is equal to minus infinite to infinite x of n z to the power minus of n. Is equal to minus infinite to infinite. The value of x of n is 1 to the power 1 by 2 n plus 3 u of n plus 3. Okay, so here u is equal, u will start n is equal to at from minus 3 onward. So it will be n is equal to minus 3 to infinite 1 by 2 the power n z to the power n and the values of 1 by 2 and multiplication of n. Okay, so in general this is the, so what will be the value of the 1 by 2 z inverse, take n out of the from n is equal to minus 3 to infinite. So what will be the representation of this function, the z transform of this? So it will start n is equal to minus 3. Okay, so n is equal to minus 3 to infinite duration. So that will be 1 upon 1 minus 1 by 2 z inverse for 1 at it start from z is equal to minus 3. So it will be multiplied by z is equal to minus 3 and 3 onwards it will go. So it will be looking like this. So would you like to solve this question? Okay, so take z at that side, it is equal to, so it is start from minus 3 but value is, so 3 will be there only. So if we take, it will come z to the power 4 z minus 1 by 2. Okay, so the correct option will be D. Are you getting? Okay, so the next problem is, if the z transform of the signal x of n is x of z with ROC R1 less than mod of z less than R2, then the z transform of x of minus n is, so I think already have you gone through the properties of the z transform. So if z transform of the signal x of n is x of z and or ROC belongs to this, then the z transform of x of minus n will be x of 1 by z and it is represented as x of z inverse, and ROC also will be getting opposite. Okay, so ROC will be the 1 by R1 greater than mod of z and greater than 1 by R2. Okay, so what will be the correct answer for this question? That is a option B, that is x of z inverse with ROC 1 upon R2 less than mod of z less than 1 upon R1. Okay. Okay. So the next question of this session is the convolution of a signal x of n is equal to del of n minus 2 del n minus 1 plus 3 del n minus 2 minus 4 del n minus of 3 and h of n 2 del of n plus del n minus 1 in z domain is given by. What will be the convolution of this two signals in the z domain? As we know that convolution of the two signals in the time domain is represented by y of n is equal to x of n convolution of h of n, and the from the properties of the Z transform in the Z domain, convolution of two signals is represented by multiplication of two signals x of z into h of z. So first we need to find out the Z transform of these signals, these two signals, then multiply them. Okay. So what will be the Z transform of the x of n? That is represented by x of z. Del of n is 1 only minus 2 z to the power minus 1 z transform 2 minus 2 del n minus 1 will be 2 minus 2 z inverse plus 3 z to the power minus 2 minus 4 z to the power minus of 3. Okay. Similarly, the z transform of h of n represented as a h of z. H of z is equal to 2 del of n, z transform of del of n is equal to 1 plus z inverse. What will be the y of z? Just multiplication of these two signals. Okay. So 1 minus 2 z inverse plus 3 z to the power minus 2 minus 4 z to the power minus of 3. Multiplication of 2 plus z inverse. So what will be the correct answer? Just match this. So this is a convolution operator. So this is first incorrect option, and just match with option B, 2 plus z inverse multiplied by 1 minus 2 z inverse plus 3 z to the power minus 2 minus 4 z to the power minus 3. So correct option will be option B for this question. Okay. Okay, so the next question. A sequence x of z is equal to z to the power 4 plus 2 z square plus 4 plus 3 z inverse plus 4 z to the power minus 2 plus 6 z to the power minus 4 plus 5 z to the power minus 5 is applied as a input to a LTI system with impulse response h of n is equal to 2 del n minus 3. The output at n is equal to 4 is option A 2, option B 4, option C 6, or option D 8. So would you like to try this question first? This is a very easy question, easy one. So this time I will wait for 1 minute so that you can solve, then I will go through this question. Okay. And try to answer this question in the chat box as well if you are solving. Just first try to find out the Z transform of h of n, Then you have to multiply this with x of z and find out what is the value at n is equal to 4. Okay, so let's solve this question. So what will be the h of z? H of z will be 2z to the power minus of 3. Okay, as already told you, in the z domain, this is a multiplication of the two signal x of z and h of z. So in order to find out, just multiply these two signals. Already x of z is given. We have find out h of z. So x of z multiplied by h of z. Okay. So what will be our x of z? X of z is equal to z to the power 4 plus 2z square plus 4 plus 3 z inverse plus 4 z to the power minus of 2 plus 6 z to the power of minus 4 plus 5 z to the power minus of 5 multiplied with h of z, that is 2 z to the power of minus of 3. Okay, so multiply with each of them. So what will be the 2 z to the power 4 minus 3 1. So 2z plus 4 z inverse plus 8 z to the power minus of 3 plus 6 z to the power minus of 4 plus 8 z to the power minus of 5 plus 12 z to the power minus of 7. This is 12 plus 10 z to the power minus of 8. Just make it correctly. This is 12. Okay. So what will, if you will change y of z into form of y of n in the time domain? So what will be the values? 2 del n plus 1 plus 4 del n minus 1 plus 8 n minus 3 plus 6. Here del will be there. Del n plus 4 plus 8 del n plus 5 plus 12 del n plus 7 and plus del 10 del n plus 8. So what will be the output at n is equal to 4? So at n is equal to 4, the value is 6. So the correct answer is 6. The value at n is equal to 4 is 6. 4. 6, sorry. And this will be the minus only. N minus 4, n minus 5, n minus 7, and n minus 8. Okay. So the correct answer for this question is 6. Okay. So next question. The initial value of the signal x of n whose z transform is given by x of z is equal to z square plus z plus 1 divided by z plus 1 plus multiplied by z plus 2 is what will be the initial value of this function? As we have seen the formula of initial value theorem, so we have to directly put the value of x of z in that and find out what will be the initial value of this question. So I'm giving again 1 minute so that you can solve, otherwise I'm going to solve it. Okay, so let's wait for 1 minute. Would you like to give an answer in the chat box? Yeah, 1. Okay, great, good. Okay, then let's solve this question for others. So the initial value theorem is x of 0 is represented by limit z tends to the infinite x of z. This is the initial value theorem for z transform. Okay, so what is our z? X of z, this is, so just put infinite z square plus z plus 1 z plus 1 z plus 2. So first read this part, limit z tends to infinite. How we are representing infinite? Infinite is represented by 1 by 0, correct? So z square plus z plus 1 is what will be the z square plus 3z plus 2. So for in order to attain this, the value is infinite, so that we can't put it directly. So first divide in the both numerator and denominator, divide by z square. So when we are dividing it with the z square, then 1 plus 1 by z plus 1 by z square. Similarly, in the denominator, this will be 1 plus 3 by z plus 2 by z square. Okay, so while putting z infinite, so all will be the 0, these values, only 1 will come. So the correct answer for this option B, that is 1. Okay. Okay, great. So we will moving on to the next question. Okay. Okay. So the next question is the inverse z transform of x of z is given, that is x of z is equal to 1 plus z to the power minus 3 z plus 1 by 3 plus z square divided by z minus 1 by 2 is, what will be the z inverse z transform of this function? How you can find it? So already I have recapitulated this point. There are three methods for finding the inverse z transform. Okay, so you can find it in any way. So if you know directly what will be the answer, otherwise you can use it for using partial fraction or long division method also. So just we are going here directly. Okay, as you know that what is a inverse z transform of 1, del of n is equal to 1. So what will be the inverse z transform of 1? That will be the always del of n. Okay, so x of n will be first del of n. And what will be the inverse z transform of this part? So just solve it. Z to the power minus 3 z plus 1 by 3. How you can write this? You can take this one. So z to the power minus 4, that one will go also 1 by 3 z inverse. Okay, so if we put z to the power minus 4 outside right now, and then what will be the inverse z transform of 1 divided by 1 plus 1 by 3 z inverse? Have you seen that what will be the z transform of normal unit step function, that is 1 upon 1 minus z inverse? So here is a positive sign, so that means there will be minus 1 by 3. That's why that will go on positive. So what will be the inverse z transform of this? This will be the minus 1 by 3 power n, and here z to the power minus 4 already is there, and u of n. Okay, so the inverse z transform of whole function will be the minus 1 by 3. Here 4 factor, here 4, the delay is 4, so n minus 4 and u n minus of 4. Okay, so z transform of this part will be the minus 1 by 3 to the power n minus 4 u of n minus of 4. Okay, so we can write it here, minus 1 by 3 n of minus 4 u n minus of 4. Okay, so what will be the z transform of this part? Similarly, you can solve it also. So when you are taking the taking the, so we will write it here next. So I'm solving it here. Okay, where is it? So that will be the z only if we divide by z in numerator and denominator. So 1 minus 1 by 2 z inverse. So there is a one positive delay. So un plus 1 will be there. And the whole function will be like this 1 by 2 n plus 1 and n plus 1. So if you are adding here, so it will become 1 by 2 n plus 1 u n plus n 1. So okay, so match this with the answers. Which one is the correct answer? X of n will be the del of n plus minus bracket in 1 by 3 n minus 4 u of n minus 4 plus 1 by 2 n plus 1 u of n plus 1. So the correct answer will be the A only. Okay. Yeah, correct answer is A. Okay. So, so what is the nature of the causal signal whose pole zero plot is given below? So what will be the nature of this causal signal which pole zero plot is given like this? So as you know that this is a real part and this is the imaginary, and overall here this all these are the jet plane, and already you have seen in the video lecture this is the unit circle where r is equal to 1, this part, but here r value is less than 1, that means if r is this much, okay, this much only r must be, and this is the angle of omega naught. So if the poles are inside the unit circle, then what is the nature of the signal? Have you seen that if it is at this at unit circle, this is a oscillatory in nature, and if it is outside the unit circle, then the signal is like this, increasing, rising signal. And if poles are inside the unit circle, then what is the nature of the signal? It is a decaying in nature. Like, wait, yeah, like this. Already you have shown in the previous slides also. So the correct option is, if plot is given, pole zero plot is given like this and poles are inside the unit circle, then the nature of the signal will be the decaying signal. So the correct option is C. Okay, great. Are you getting, guys? Are you getting these points? Or you are solving questions with me or not? Can you answer it, please, so that I can get some idea also? Okay. So we will moving on to the next question. A system is described by y of n is equal to 3x of n plus 2x of n minus 1 and minus y n minus 1. Identify its inverse system. So how you will find out the inverse system? Anyone knows how to find out? So the options are y of n is equal to 3x of minus n plus 2x minus n plus 1 minus 4y minus n plus 1. Option B is x of n 1 by 3 y and in bracket y of n plus 4yn minus 1 minus 2x of n minus of n. Okay, then option C is y of n is equal to 1 by 3 x of n plus 4x of n minus 1 minus 2y of n minus 1, and option D is 1 by 3 brackets y of minus n plus 4y n minus of n plus 1 minus 2x of minus n plus 1. Okay, so how will you find out the inverse system? So the first one is change x to y and y to x. Okay, so what will be the, so it will be represented by x of n is equal to 3 y of n plus 2y n minus 1 minus 4x n minus 1. Then find out the output. So just keep 3y of n this side and all others are x of n minus 2 y of n minus 1 plus it go this side, then 4x n minus of 1 is equal to 3y of n, right? So what will be the y of n? So 1 by 3 in brackets x of n plus 4x n minus of 1 minus 2y n minus 1. So what will be the correct answer? Just match this with this one. So the correct answer will be the option C. Yeah, option C is the correct answer for this question. In order to find out the inverse system, just change input to the output, output to the input, and try to find out this output. Okay. Okay. So the next question is, these are the basic questions based on the properties of a Z transform and ROC. So I think you can answer these questions as well. This is a theoretical type question. So what is the ROC of Z transform of a finite duration anti-causal signal? So I think I already recapitulated these points in the previous slides, as well as you have also gone through the video lectures also. So can anyone answer these questions? These are the basic questions. Please try to answer this, at least this question. Yeah, waiting for 1 minute so that you can answer this question. Okay. That what is the ROC of Z transform for finite duration anti-causal signal? Okay. So option A is Z is equal to 0. Option B is entire Z plane except Z is equal to 0. And option C is entire Z plane except Z is equal to infinite. And option D is Z is equal to infinite. So finite duration anti-causal signal ROC will be the entire Z plane except Z is equal to infinite. Okay, so as you know that what is a causal and anti-causal signal. So the causal signal is said to be causal if input output depends on the present and past values but does not depend on the future values. Okay, and in other way, if signal is anti-causal, then it must be depend on the future value. So it will go to the signal is anti-causal, so it will be the outside of the Z plane. So it will be the entire Z plane except it is to infinite. Okay. And the next question is a discrete time signal x of n is equal to 4 del n minus 2 plus 2 del n minus of 4 has a Z transform x of z if y of z is equal to x of minus z is the Z transform of another signal y of n, then which of the following is true? Option A, y of n is equal to x of n, y of option B, y of n is equal to x of minus n, and option C, y of n is equal to minus of x of n. Okay, so let's try to solve this question. So as we know that x of n is given, so what will be the Z transform of this x of n? X of z will be 4 z to the power minus 2 plus 2 z to the power minus of 4, and here it is given if y of z is equal to x of minus z, then z transform of this signals in the time domain y of n will be, what will be the y of n? So first we will find out the y of z, that is x of minus z. So just put at where z is there minus of z or minus 2 plus 2 minus of z to the power minus of 4. So here square term here z to power minus 4, so there is no difference in this, so that will come z to the power minus 2 plus 2 z to the there will be no minus z to the power minus 4, which is similar to the x of z only. So if you will take again inverse this y of z in the time domain, that will come 4 del n minus 2 plus 2 del n minus of 4, which is equal to x of n. So what will be the correct answer? Correct answer is y of n is equal to x of n. So the correct option will be the A only. Okay. Yeah. Okay. So the next question. Compute the convolution of its following signals using Z transform. The signals are given x of n is equal to del of n plus 3 del n minus 1 minus 2 del n minus 3, and y of n is given is 4 del of n plus del n minus of n, and identify the correct option to represent it. They have given option in the form of Z transform. That means we need to find out first Z transform of this signal in this signal. Then, as we know that if the in the time domain, if convolution is represented by two signals with x of n, convolution of y of n, here y of n is given. So in the time Z domain, it is just multiplication of two signals y of z. So first we need to find out the x of z and y of z, then multiply both of them. So already we have solved this type of problem in previous question. So I'm giving you 1 or 2 minute time so that you can solve this question and answer this. So try to solve it, just waiting for 1 minute, then we will solve it. Try to answer at least if you are solving. Okay. Let's solve this question. So what will be the x of z? X of z will be del of z transform of del of n is 1 plus 3 z inverse minus 2 z to the power minus of 3. Okay, and similarly the z transform of y of n will be the y of z, that is 4. Z transform of del of n is 1, so that will be the 4 only, and plus z inverse. So in the z domain, the convolution of these two signals will be simply a multiplication. So x of z and multiplied by y of z. That's h of z. So 1 plus 3z inverse minus 2z to the power minus of 3 and multiplied by 4 plus z inverse. Okay, so let's see what will be the correct option. Just match this answer to this. So the correct option will be the A only. So it will be 4 plus z inverse multiplied by 1 plus 3 z inverse minus 2 z to the power minus of 3. Okay. Yeah. Okay, so now let's move on to the next question. Determine the initial value of the signal represented by x of z. What will be the initial value of this function? Already we have solved this type of problem. As I know that, we know that initial value theorem is represented by limit z tends to infinite x of z. So x of z is given there, so limit z tends to infinite 1 plus 3z inverse minus 2z to the power minus of 3. It is already in the form of 1 by z, so it does not require to divide or multiply by any function. So directly we can put 3 by z and it will be minus 2 to the power 2 by to the power minus of 3. When we will putting the limit, so it will be 0 and this will be also 0, only 1 will come. So the correct answer is option D, that is 1. Okay. Okay, so now let's move to the next question. That is a system is described by y of n is equal to 2x of n plus 3x n minus of 1 minus 2y n minus 2. Identify its inverse system. So already you have solved this type of question. Already one problem we have been solved. So try to solve this question first, then I will be going through this question. Okay, so I am giving 1 minute time so that you can solve this question. Then I will solve this question. In order to find out the inverse system, just try to replace x to y and y to x. Then find out the output, that is a y of n. Okay, let's solve this question. So what I told you, in order to find out the inverse system, just try to replace x to y and y to x. Okay, so here y of n will be replaced by x of n. So yeah, y of n will be replaced by x of n is equal to 2x of n replaced by y of n plus 3y n minus 1, that is 3, minus 2x n minus of 2. Okay, y is replaced by x. Then find out the value of yn, that is here. So what do we need to do? Just try to uh, do that in order to find out y of n. So just in the left hand side we will take these values to the left hand side. So x of n minus 3y n minus 1 plus 2x n minus of 2. Okay, then y of n is equal to 1 by 2 in bracket x of n, just rearrange the term, plus 2x n minus 2 minus 3y n minus 1 and close the bracket. So just match this answer to this one. So the correct answer will be the option B, that is 1 by 2 x of n plus 2x n minus 2 minus 3x n minus 1. Here some mistakes are there, so that will be the y. Okay, because this is the x, so it must be y. Yeah, so now we have to what is no. Yeah, actually, yes, yeah, there is a correction in this answer. Okay, so the correct Option will be option D. So are you solving these questions? Yeah, okay. So moving to the next question. Yeah. The question 16 is a point Z1 has been plotted in the complex Z plane as shown in the figure. Which one of the following is the plot of Z2 is equal to 1 by Z1? So this is a Z plane of a point Z1. Then which of the following is the plot of Z2, that is 1 that is equal to 1 by Z1? So as we know that this one is a unit circle and it is a Z1 is the inside the unit circle. So this point in Z1 is inside the unit circle. So it must be R less than 1. And how much angle it is made? This is approximately 45 degree, or you can say theta or omega. Okay. So R is less than 1 and angle theta is equal to 45 degree, or you can say omega is equal to 45. Let's say. Okay. So what will be the Z2? Z2 is equal to 1 by Z1. So what will be the Z2 in order to find out if it is, let's say it's mod of R, mod of R, Z is R and angle is 45 degree. So 1 by Z1 is equal to 1 by mod of R and angle 45 degree. So if we will take angle in the upper side, it will be the minus, angle will be the minus 45 degree. Okay. Angle minus 45 degree divided by mod of R. Okay. In that case, if angle is minus 45 degree and mod of R here is less than 1, if it is goes down, then it must be R is greater than 1. So if it is greater than 1, so it will be the outside the unit circle. Okay. So firstly, which point is related to the outside the unit circle? There is option C or option D. It is represent, but here angle is minus 45 degree, but here angle is showing 45 degree. So it will be the correct option is D. Angle minus 45 degree and the units mod of R must be greater than 1. So the correct option will be the option D. Okay. Okay. So have you understand this question? Okay. So moving to the next question. Okay. Find out the Z transform of the following sequence, that is given as x of n is equal to 10 sine in bracket 0.25 pi n u of n. What will be the Z transform of this signal? Here already I have solved this question, but try to solve it in this session. Then I will describe it how we will solve it. So already have you seen in the table there are some already Z transformed of of sine omega or sine theta n is given. So try to find out, take the formula from there and put the values in that formula and find out the x of z of this signal. This signal. So I am taking in that table so that you can note it down. Okay, this is the table. We have to find the value of sine an, that is in this from here. So what is the formula? Z sine of a divided by z square minus 2z cos of a plus 1. Okay. So let's see what is the value of a. This is the z transform of sine an. This one. Okay. So what is the a here? A is 0.25. So what is the z transform of this signal? This signal is here 10 is a constant, so it is outside. So 10 z sine a is there, no? Okay, sine 0.25 pi and is not there as it is z square minus 2z cos a is 0.25 pi plus 1, and try to find out the value of 0.25 pi sine 0.25 pi in the calculator. As already I have suggested you, keep one calculator with you while solving the problem. So what is the value of sine 0.25 pi? 0.25 pi means pi by 4. So what is the value of sine pi by 4? That is 1 by root 2. So what is the value of 0.707? So sine 0.25 pi value is 0.750 0.707. Okay, divided by z square will be there minus 2z, and what is the value of cos pi by 4? That is will be the same 0.707 plus 1. Okay, so if you multiply 0.707 multiply 10, so that will be the 7.07 z is there divided by z square minus, if you multiply 0. So it will be the 1.414 z plus 1. So this is the answer of this question, 7.07 z divided by z square minus 1.414 z plus 1. Okay, this is a z transform of this signal. Okay, have you understand this question? How to solve it? Will table will be given for exam? No, actually you have to learn these basic of the Z transform. What is it? For example, what is the Z transform of del of n? What is the Z transform of u of n? And what is the Z transform of sine of omega n or sine of some value a or n? Or you can solve it also. See how you will find out. Okay. So moving to the next question. Next question, find the Z transform of the following sequences. The sequence is given of is x of n is equal to e to the power minus 0.1 n cos 0.25 pi n u of n. So already I have told we have included one table in this slide. So from there you can directly take the formula and solve it. So I am going to take you in that table, and just first we will give you 1 minute time, so that 1 minute or 2 minute time, so that you can solve. Otherwise I will explain it. Okay. Okay. So which formula will be applicable here? This one, that is in the form of cos e to the power minus of a n cos dn u of n. So write down this one. So have you noted down this one? Okay, I hope you have noted down. I am moving to the question. Okay, so try to solve this question first, then I will explain it. Already answer is given here, but try to solve it. Try to find out what is the value of e to the power minus 0.1, and already you know that what is the value of cos 0.25 pi. Cos 0.25 pi is written as pi by 4 also, cos pi by 4, and cos pi by 4 value I think all of you know. So okay, let's solve this question. The z transform of this function can be written as x of z is equal to, already I have noted down this formula, z to the power minus e to the power minus 0.1 as it is given, and cos 0.25 pi divided by z square minus 2 e to the power minus 0.1 cos 0.25 pi plus 1, no, plus e to the power 0.2. Why it is 0.2? Okay, we'll go plus 1. Let me check. Oh, e to the power minus of 2a is there, so that's why 0.2. Okay, so z, when you are calculating the e to the power minus 0.1 value and the cos 0.255, the cos 0.255 value is 0.707, and similarly e to the power minus 0.1 value will multiply by both of them, then you will find 0.6397 divided by z square. Then find out cos 0.255 and e to the power minus 0 in value and multiply this value to the 0.6. These values is 0.6397 and multiply it with 2, it will come 1.2794. There is a z term is also there, plus e to the power minus 0.2 value is 0.8187. Okay, so the option you can solve it more like this: z square minus 0.6397 z divided by z square minus 1.2794 z plus 0.818. Okay, so z transform of this function is this one. Okay, have you got it? Okay, so we can move the next question. Okay, great. Okay, so moving to the next question. Find the inverse Z transform of the following sequence. Which is given an f of z is equal to 2z square plus z divided by z square minus 1.5z plus 0.5. As you know that there is 3 methods of finding out the inverse Z transform. Already one method you have explored in the previous question. The next method is long division method, which is given here. If numerator and denominator power is equal, you can easily find out by long division method. Okay, so just we need to divide it and find out what is the next sequence of this function. So solve it here: z square minus 1.5z plus 0.5, 2z square plus z. And we will try to divide it continuously and find out the sequence, what will be the next sequence or in the time domain. Okay, so first what we will do, so first try to match it here. So here z square term is there, but in order to cancel out, it must be multiplied by 2. So first multiplied by 2 in this. So if you multiply by 2, then it will come 2z square minus 1.5 multiplied by 2, that will become 3z, and if you multiply 0.5 multiplied by 2, that will become 1. Okay, So here plus, here minus, minus, minus. So cancel it out. What will be the, here minus and minus is plus, so it will become 4z minus is here, so minus 1. Okay. So what will be the next sequence? Here 4 is there. In order to cancel out, we have to multiply first 4 and here square here z, so 4 z inverse. We have to multiply by 4 z inverse. So it will, when you multiply, it will come 4z minus 4 is 1.5 multiplied by 4. How much it will be? 6. If you z and z inverse will be cancelled out, only 6 is there. Then plus, yeah, it is a plus. 2 plus. Okay. Then 4 z inverse multiplied by 0.5. So it will come 2 z inverse. 7 is plus plus minus minus minus. It will be cancelled out. What will be the value of here? 5 minus 2 z inverse. If we continuously divide it and multiply it by this, then the sequence will be coming like this: 2 plus 4 z inverse plus 5 z to the power minus 2 plus 5 z to the power minus 3 plus 5 z to the power minus 3 and so on. Okay. So the sequence of this function will be, only if we are taking here, it is, there is no that at 0 it is, the value will be 2, and at n is equal to 1 the value is 4, at n is equal to 2 the value will be the 5. It can be represented by this. And if you want to represent it in this form, in the form of f of x of n or f of k or f of n, so it is represented by 6 u of k minus 4 multiplied by 0.5 k. So in order to verify this, let's try to put the values of k here and see, we will see whether we will come getting these values or not. Okay. So if we first put k is equal to 0, so u of 0 is equal to 1 and 0.5 power, here it is 0. So only 4 is there, 0.5 power 0 only 1, 6 minus 4 will be, we will get 2. Next, if we put at 1 k is equal to 1, so u of 1, the u is a unit step function. So at all points the magnitude will be 1 only. So it will be 6 if you are putting k is equal to 1. So 6 minus 4 multiplied by 0.5. Here we are putting k is equal to 1. So 0.5 power 1. It will be the 0.5 only. What is 6 minus 2? What will be value? 4. So at k is equal to 1, value is 4. So it is coming 4. Okay. So let's see what will come at k is equal to 2. So at k is equal to 2, 6 minus 4 multiplied by 0.5 square. That means 0.25. Okay. So 0.25. So 0.25 is, and multiplied by 4, it will become 1 only. 6 minus 1 is 5. Okay. So in odd, so it is getting 5 at k is equal to 2. Similarly, you can find the other values also, 0. At k is equal to 3, and that will become 5, 5, 5. So it can be represented in this form. Okay. So have you got understood this question? How you will solve and how you will find out the answer? this sequence is correct, and if you want to write down the compact form, so you can write down in this form on also. Okay. Okay, so moving to the next question. Okay. So find the inverse Z transform of the following sequence. What will be the Z transform of this sequence? The Z transform is given as x of z is equal to 1 upon 1 minus z to the power minus 2. So have you gone through the other two methods? Let's try to solve this third one. That is a partial fraction method. Okay. So what will be the, how you can get, first we try to write down in the other form also. You can write 1 minus z inverse and 1 plus z inverse. So when you multiply these two sequences, you will get this one. Okay. So in the partial fraction, what we can do, you have to find out 1 minus z inverse plus, try to find out first a and b values and put here 1 plus z inverse. So how you will find out the values of a and b? Already have you gone through the video lecture? So just a. So what is the denominator of a? 1 minus z inverse. So 1 minus z inverse and multiplied by x of z. Okay. So 1 minus z inverse and this 1 minus z inverse will be cancelled out. So you will get 1 plus z inverse at z inverse is equal to 1. Z inverse is equal to 1. If z inverse is equal to 1, so what will be the value of a? 1 by 2. Got it? And similarly, you can find out the value of b also. So what is the denominator in the b? 1 plus z inverse. 1 plus z inverse x of z at z inverse is equal to minus 1. Okay. So 1 plus z inverse and 1 plus z inverse, 1 minus z inverse will be there only at z inverse is equal to minus 1. So when we are putting z inverse is equal to minus 1, then again we will get 1 by 2. So what will be the value of 1 by 2? 1 minus z inverse plus 1 by 2, 1 plus z inverse. So if you take 1 by 2 outside, because it is common in both, so what will be the, so it will be the 1 divided by 1 minus z inverse. What is the inverse Z transform of this? Which sequence Z transform it? It is a sequence u of n. And similarly, here 1 is there, it is hidden and we are not writing 1 here. So here it is a plus. So here it will come minus 1 to the power n u of n. Okay. So answer is this. Inverse Z transform of this sequence is x of n is equal to 1 by 2 in bracket u of n plus minus 1 to the power n u of n. Okay. You got it how to solve this problem? Okay. So these are the questions for this live interactive session for week 3. week 3 live interactive session. There are 20 questions we have solved which are similar to a assignment problem. So it will be the helpful for while you are solving the assignment questions. Okay, if you have any doubt or you want to ask anything, you can ask now. If you want to ask anything, anyone? I hope all of you understand these questions and able to solve this problem as well as assignment problems. And these questions are helpful for exam also. Anyone have any doubt related to these questions or anything? Have you understand these questions? Okay, great. Have you any doubt? You have any doubt? If you have any doubt, you can ask here. I hope all of you gone through the video lectures also and these questions. Have you solved these questions? Okay, great. If you have not, if you don't have any doubt, you can, now we can stop our session here. If you don't have any doubt, if you want to ask anything, you can ask also. You don't have any doubt. Okay. Okay. So now we can close this session. Thank you everyone for attending this session. Okay, you can leave now this meeting. Okay, thank you.